Hello friends, in today's question, a solid sphere of radius r acquires a terminal velocity v1 when falling due to gravity through a viscous fluid having a coefficient of viscosity nu. The sphere is broken into 27 identical solid spheres. If each of these spheres acquires a terminal velocity v2 when falling through the same fluid, then the ratio v1 by v2 is equal to. So this is a question which is based directly on the formula, and we know that the terminal velocity for a solid sphere terminal velocity for a solid sphere it is given as V is equal to is 2 by 9 r square rho s rho f multiplied by g and divided by nu, where this r is the radius of the sphere, smaller rather, is radius of sphere, and rho s is density of sphere, rho f is density of fluid, g is the acceleration due to gravity, and this nu is coefficient of viscosity of fluid. Coefficient of viscosity. So in this case, let us start with the original sphere. Or original sphere, small r will equal to capital R because radius is given as capital R, and the rest of the things we can keep same, and the velocity is given, our terminal velocity is given as v1 rather, so you can say v1 will be equal to 2 by 9, and this comes as r square rho s rho f g upon nu. Now this original sphere, let's find out its volume. So you can say volume of original sphere, we are going to call that as V volume, and that will be equal to 4 by 3 pi r cube, and this original sphere is broken into 27 identical spheres, and let us say that the radius of the smaller spheres is small r. Radius of smaller, that is broken spheres, is equal to small r. So the volume of smaller spheres, let us, it is called as VOL small, will be equal to 4 by 3 and pi r cube. So there are 27 smaller spheres, so we are going to multiply this by 27 and will be equal to the original sphere. So we can say volume will be equal to 27 multiplied by the volume of the smaller sphere. Now this relationship is going to give us a relation between the small r and capital R, and this bigger is given as 4 by 3 pi r cube, and smaller will be 27, this will be 4 by 3 pi r small cube. 4 by 3 pi cancels out, so from here we can write that our small r will be equal to capital R divided by 3. So So we got the relationship between the radius of the original and the broken one. And for the broken one, we are given that its terminal velocity is given as v2. So you can say for smaller sphere, the terminal velocity it will be given as v2. v2 will be equal to 2 by 9, and this becomes r cube, and we have this rho s rho f multiplied by g and divided by nu. And in place of this small r, sorry, not r cube but r square, in place of this small r we can put capital R by 2, because we already know relation between small and capital R. So we can write this as 2 by 9, and this becomes r by 3 whole square, and this is our rho s rho f nu multiplied by g. So we get this v2 will be equal to 1 upon 9. We can combine next rest of the things, that is 2 by 9 multiplied by r square rho s rho f g upon nu, and this entire term is our v1. So therefore we get v2 is equal to 1 by 9 times v1, and we have to find out the ratio of v1 by v2. So from here we can say v1 by v2 is equal to 9. So the options that are given to us, option number A is the correct option. So we can say option A is correct. So this is quite simple based on directly the formula for the terminal velocity. Thank you.